Good morning to all. Myself T.M. Divakar, working as an assistant professor in ANTC in Sharad Institute of Technology, College of Engineering. So in the previous video, we studied about the classification of the electrical networks as well as some basic laws, KVL laws, Ohm's laws. So today we are going to see some basic energy sources as well as the series circuit and parallel circuit. So let us come to the point. Energy source. So there are basically two types of energy source. One is a voltage source and current source. In that again it can be subclassified into the ideal source and practical sources. Means the voltage source, it can be ideal source or practical source, and the current source, it can be ideal source or practical source. So let us see one by one. First one is a voltage source. In that, ideal voltage source. So what is the definition of the ideal voltage source? It is an energy source which gives a constant voltage across its terminal, irrespective of the current drawn through its terminal. So simply you can just consider that ideal voltage source is a energy source which gives the constant voltage at its terminal. So this is the symbol of the ideal voltage source. Figure number A is the symbol of ideal voltage source. So this is the symbol of the ideal voltage source. So the polarity has given plus and minus. Here it is a load is connected at its terminal. So this is the load voltage, or load is connected at its terminal, means this is the load voltage. So according to the definition, this is the voltage source, Vs is the voltage source, and it gives a constant voltage at its terminal. Here I have mentioned at any time the value of the voltage at load terminal, means VL, it remains same. That is called as the ideal voltage source. Next one is a practical voltage source. So in practical voltage source, every voltage source, that is a Vs is a voltage source. So every voltage source has a small internal resistance which is called as a RAC. This is the RAC. This is a small internal resistance, and it is connected in series with the resistance. So this is called as a practical voltage source. Practical voltage source means just simply one voltage source which is connected with resistors, and that should be in a series, and it is represented by RAC. So this internal resistance is called as a RSE. It is represented by RSE. Okay. So what is happening in practical voltage source? So because of this RAC, that is the internal resistance source which is connected in series with the voltage source, and because of this connection, the voltage at terminal decreases slightly with increase in the current. If you increase the current, the voltage at terminal, this is the positive and negative, this is the terminal voltage, V is a V, that is a VL. So terminal voltage decreases with increase in a current. So this is the practical voltage source. So in ideal voltage source, there is no change of voltage at the terminal. In a practical voltage source, the terminal voltage may get change because of this internal resistance which is connected in a series. So next point is a current source. Here is also same. The current source is again classified as ideal current source and practical current source. So first one is the ideal current source. So it is also a source which gives the constant current at its terminal, and it is irrespective of the voltage appearing across its terminal. So ideal current source, it gives the constant current at its terminal even the voltage appearing across its terminal gets changed. So this is the symbol of the ideal current source. This is the IS, this is the current source. The polarity is not given here because this is the current source. The arrow indicates the direction of the current. Here the direction of the arrow is upward, means the current flowing in the upward directions. This is the symbol of the ideal current source. So at any time the value of the current flowing through the load, here we have connected one load. This is VL is a voltage at load, IL is a current through this load. So this IL remains same through this load irrespective of the voltage appearing across its terminal. Next one is a practical current source. So what is happening in practical current source? It is same as a practical voltage source. In a practical voltage source, every voltage source has a one resistor which is connected in series, but in a practical current source, every current source, this is 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 a current source, has a high internal resistance and which is connected in parallel with the current source. So RSH, and it is represented by RSH. So RSH is high internal resistance and that is connected in parallel with the current source IS. So this is the practical current source. So because of this RSS, see the current through its terminal decreases slightly with increase in voltage at its terminal. Because of this RSH, the current through its terminal decreases with increase in voltage. So this is the difference in a ideal and practical current source. Once again, ideal current sources gives the constant current at its terminal irrespective of the voltage appearing at its terminal, and in a practical current source, every current source has a resistance which is connected in parallel, and because of this resistance the current decreases slightly with increase in voltage. Okay. Next, we are going to see what are the series circuits. What is series circuits? A series circuit is one in which several resistances are connected one after the another, and such connection is called as end-to-end connections or cascade connections. So in a diagram, so there are three resistors R1, R2 and R3, and these are connected one after another, means R1, R2 is connected after R1, R3 is connected after R2, and this type of connection is called as end-to-end connections, or it is called as cascade connections. The second point is there is only one path for the flow of current. So resistance R1, R2 and R3 are said to be connected in series, and the combination of R1, R2 and R3 is connected across the voltage source V. Here V is a voltage source and the combination of these is connected to the voltage. So means the terminal of R1 is connected to positive and the terminal of R3 is connected to the negative of the voltage source V. So in this circuit there is only one path of flow of current, and that should be the current is always flowing from positive, it comes to the negative. So here I is a current, that is the total current flowing through the circuit. See here, so there is only one path in this figure. So the current flowing through R1, the current flowing through R2 and current flowing through RT is same because there is only one path. So in a series circuit the current is same in all the resistance, but there is a different voltage across the circuit elements. So let us see the voltage distribution in this circuit. Let Phi1, Phi2, Phi3 be the voltage across the terminal of resistance R1, R2 and R3 respectively. According to this figure, Phi1 is the voltage across the terminal R1, V2 is voltage across the terminal R2 and V3 is voltage across the terminal R3. So as you know that Phi is equals to Phi1 plus V2 plus V3. This is the KVL law because KVL law indicates the algebraic sum of all internal voltage is always equals to 0 at any time. So according to the Ohm's law, we know that V is equals to I into R. This is the Ohm's law. So you can apply the Ohm's law to the R1, R2 and R3. So therefore Phi1 is equals to I into R1, Phi2 is equals to R into I into R2 and V3 is equals to I into R3. Since the current through all of them is same, so therefore Phi is equals to IR1 plus IR2 plus IR3. Taking I as a common, so in bracket R1 plus R2 plus R3. So applying Ohm's law to the overall circuit, so V is equals to I into R equivalent. So whereas R equivalent means equivalent resistance of the circuit. So R equivalent is equals to R1 plus R2 plus R3. So equivalent resistance is nothing but the algebraic sum of all the internal voltage, that is the R1 plus R2 plus R3. So you always remember that if you calculate the equivalent resistance of the series circuit, then you should be considered that the arithmetic sum of the resistances connected in the series. So therefore the total resistance is equals to R1 plus R2 plus R3 dash dash up to the Rn. This is for nth resistance in a series. Next one is a parallel circuit. Once again, in series circuit the resistances are connected one after another, and in a series circuit there is only one path for the current, and there are voltage distributions in the series circuit. Now let us see the parallel circuit. The parallel circuit is one in which several resistances are connected across one another. The word across is very important, means the resistance R1, R2 and R3. These are the resistance and they have connected one across another. So R1 is connected across R2. R1 is not connected, R2 is not connected after R1. So in this diagram, R2 is connected across R1, R3 is connected across R2. So they have to connect it in such a way that one terminal of each is connected to form the junction point. Means the one terminal of R1, one terminal of R2 and one terminal of RT, these are connected at point this. So this is a point and it should be form a junction. So while the remaining terminals of each resistance, they have connected to form the another junctions. Okay. So in a parallel circuit, so there is a different path for the current because the resistors have connected one across another. So this is the I is the total current which is flowing in the circuit. So at this junction the current is distributed. So current I1 is flowing through R1, current I2 is flowing through R2 and current I3 is flowing through R3. So there are three paths for the current. So in a parallel circuit the current is always distributed, but the voltage across the resistances R1, R2 and R3 is same. Is very important. Next point is depending upon the values of R1, R2 and R3, the appropriate fraction of total current passes through them. So if we use the value of resistance R1 is R2 and R3, they have different values, then the different some fraction of total current passes through them because it depends upon the value of the resistance. Next point. So while voltage across, as I told you that because the voltage is same. Okay. So in this diagram there is a current distribution. So according to the Ohm's law to each circuit, so V is equals to I1 into R2, V is equals to I2 into R3 and V is equals to I2 into R3. So I1 is equals to V upon R1, I2 is equals to V upon R2 and I3 is equals to V upon R3. So total current I is equals to I1 plus I2 plus I3 because here is a distribution of current. The main current is I, the total current is I and it is distributed through three different paths. So we have considered I1, I2 and I3. So as per the Ohm's law, I1 is equals to V upon R1, I2 is equals to V upon R2 and I3 is equals to V upon R3. Okay. So considering or substituting these values in equation this, so I is equals to V in bracket मध्ये, so we have taken the V as a common, so in bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. So same you can apply the Ohm's law to the overall circuit. So V is equals to I into R equivalent. So in a parallel circuit the equivalent resistance you can calculate is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So in a series circuit the equivalent resistance simply you can find out by using R is equals to R1 plus R2 plus R3, but in a parallel circuit the equivalent resistance you can find out 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In general, this is very important. If n resistances are in parallel. That is the general formula, as I said now. But if there are two resistors and they have connected in parallel, then you can use this formula: 1 upon R is equals to 1 upon R1 plus R2. That means total resistance R is equals to R1 into R2 upon R1 plus R2. So let us solve one example. Find the equivalent resistance between point A and B. Okay. So we have to find out the equivalent resistance, means we have to find out R equivalent. Okay. So before going to solve this, you can just identify the combination of series and parallel resistance. So in this diagram, you can find out the combination of series and combination of parallel resistance. Okay. So see, the resistance 5 ohm and 6 ohms are in series. So in this diagram, resistance 5 ohm and 6 ohm, these are in series connections. So in the series connection, the equivalent resistance is 5 ohm plus 6 ohm. So total equivalent resistance is 11 ohm. While the resistances, see, 3 ohm, 4 ohm and 4 ohm, these resistances have connected in parallel. So you can use the formula that in parallel circuit the equivalent resistance is 1 upon R is equals to 1 upon 3 plus 1 upon 4 plus 1 upon 4. So therefore total resistance is R is equals to 1.2 ohm. So let us redraw the circuit. Here I am redrawing circuit. Here we have connected 11 ohm, 5 ohm and 6 ohm, they are in series. So 11 ohm is total resistance, and 3 ohm, 4 ohm and 4 ohm, they have converted into 1.2 ohm. Next come to the reconstructed circuit. Now observe this reconstructed circuit. So 1.2 ohm and 2 ohm, they are in series. So again the total equivalent resistance is 1.2 plus 2 is equals to 3.2 ohm resistance, while 11 ohm resistance and 7 ohm resistance, they are in parallel. So use this formula: 11 into 7 divided by 11 plus 7. So total equivalent resistance is 4.277 ohm. Again you can simplify the circuit. Again you can redraw the circuit here. See here, 3.2 value, it comes from 1.2 and 2, the combination of the series, and 4.277, it is a combination of 11 ohm and 7 ohm. Now again you can just observe the this diagram. Here 3.2 and 4.277, they are in parallel combinations. So use this formula: 3.2 into 4.277 upon 3.2 plus 4.277, that is the total equivalent resistance is a 1.83 ohm. So you can convert, you can connect it this value. So therefore the total equivalent resistance between the terminal A and B is 1 plus 1.83. So 1.83, it is the combination of parallel combination of 3.2 and 4.2. So total equivalent resistance between terminal A and B is 2.83 ohm. So like this we are going to solve more and more example. After that you will come to idea of solving the series and parallel circuit resistances. Thank you.